So now we should be live. And good evening, good afternoon, good morning, everyone, to our Everyone Can Contribute Cafe, our fourth iteration. And today I'm super excited to welcome developers, founders, everyone from is it Jina.ai? Jina? I don't know how to pronounce Jina. So I would say it's best, Alex, if you want to start the introduction round and then hand it over just to share a little bit about yourself.
Okay, more than happy to. I'm Alex CG. I'm the open source evangelist here at Jina.ai. We're a neural search company based out of Beijing and Berlin, though we have people all over the world and we're always looking for more. So we'll be talking a lot more about Jina moving forward, so I won't hog my time here, and we can go on to my colleague, Rituja, who will also be speaking.
Hello, this is Rutuja.
Do you want to give a quick self-intro?
Yeah, so I work with Jina.ai as an AI engineer, and I'll be giving a brief introduction to the technical aspects of Jina, and we'll be doing a deep dive into the internals and the tech stack.
Okay, next up, we've got Pei Shan.
Hello, everyone. My name is Pei Shan, but you can also call me Pei. I'm the developer relations specialist at Jina, working together with Alex. And we both are based in Berlin. And yeah, nice to meet you. And I'm very looking forward to the talk later.
Yep, lovely, sunny, horrible, rainy Berlin. Pratik?
Yeah, hi guys, I'm Pratik and I work as an AI engineer at Jina, and we are trying very hard to make neural search easy for you. So do try out Jina if you find it of use to you. I think you will love it.
Nicely said. Anyone else?
Yeah, I would hand it over to Niklas.
Okay, so I'm Niklas. I'm currently working as senior DevOps engineer at Verity. I'm today like Jon Snow, so I don't nothing. And I'm happy to learn new things also about AI. Yeah. So I think the next one will be Michael, the other Michael from Austria.
Hi, my name is Mike Kleiner. I'm from Austria. I work at a company called ZKW. We build headlamps, for example, for the automotive industry. And I personally be a product manager and software engineer for high-performance computing software like ray tracer engines and 3D CAD software. And I'm also really interested in this AI-based search topic because I can need such thing. So.
And last but not least, I'm the other Michael. I'm also originally from Austria, but I moved to Nuremberg, Germany 8 years ago. I've been with GitLab since months now, and I'm the kind of crazy guy hosting all the coffee chats we have together. Yeah, and I would say, I think, Alex, you will be kicking us off.
Yep, I'll start kicking. Okay, I'll share my screen and we'll get going. Get this show on the road. Okay, can everyone, see everything?
Yeah.
Okay. Excellent. So yeah, we've given a quick intro to everyone here. Here's a chance to look at all our lovely faces once again. So yeah, Jina. Jina is an open source search framework. We're powered by deep learning. We're cloud native, and we've been going since early this year. We're a pretty new startup. but we're backed by a full-time venture-backed team. So I think there are about 20, maybe 30 of us now. Yeah, so let's dive into these things a little bit more. So by search framework, I don't just mean a search engine that you install and just plug and play, though we are pretty simple to use. We're a framework where you can use to build your own search engine to search any of your data that you want. Cloud native, meaning we support all the lovely buzzwords like containerization, microservices, all of those. And deep learning, well, we use all of the top deep learning frameworks, things like TensorFlow, PyTorch, MindSpore, all the ones you know and love and have maybe played with, maybe not. The main part of Jina is Jina Core. So it's a state-of-the-art design pattern for search workflows, use the latest AI, yada, yada, yada. Works out of the box. The key points are we're universal. So we run on a lot of platforms, Mac and Linux right now. Windows is in the works. Not running on microwaves yet, but you can run us on a Raspberry Pi. We're really easy to use. I knew barely anything about machine learning before I joined, and I've been building my own examples with Jina to search like all the lines from Star Trek: The Next Generation, because that's who I am. Cloud native, as I said, and with that cloud nativity comes scaling. We're extensible. We have a hub where you can, a bit like Transformers hub, so with just a few lines of code, you can suck in models from somewhere else and use those. And we're state of the art, like using TensorFlow, PyTorch, Onyx, FAS, Annoy, all of the common machine learning libraries. The other thing to bear in mind is that we are still very new. We haven't hit version 1.0 yet. So if you do use us, be aware that we're dynamic, we're building fast, things may change from release to release. And hey, if it breaks, you get to keep both pieces. So what's not to like? So when I talk about a search framework, the common question would be, oh, well, what does it search, right? Well, hey, what doesn't it search? We do text, we do images, we do audio, we do video. And that's not all. We do cross-modal and multimodal, all for the low, low price of, well, nothing at all, because we're open source. So cross-modal and multimodal are words that not many people really know. I didn't know before I came on board. So when I'm talking about cross-modal, I mean something like Google Images. You plug in text and images come out. And we've got an example of this I'll show you now. This is pretty new, but yeah, as you can see here, typing in someone wearing a hat, and someone wearing a hat comes up. Or we've got a kid playing, and we've got kids playing. So you get the picture. On top of that, we offer multimodal, which I think is even more exciting. So cross-modal, you put in one query in one form of media like text, you get out another in another form of media like graphics. But with multimodal, you can have image to text and text to text. For example, if you're searching red Nike sneakers imported, Jina can look at all your pictures in your product catalog of sneakers. And with its deep learning models, it can find the ones that are red and that are Nike. But just by looking at a picture, you can't tell whether these are imported or not. So it'll also search through the text attached to those images. So if you want to build the next Amazon or something, this would be a good use case. A few cool features. It's really quick to get going. We use Cookie Cutter. So that'll help you create all the boilerplate code you need just by running a command from your terminal. It'll give you interactive choices. You just hit 1 or 2 or 3 or 4 to choose text or graphics or whatever you want to search. It's cloud native, as I said, universal, all kinds of data. first-class support for AI models, Fasanoi, Onyx, all the lovely buzzword ones, and plug and play. So with Jina Hub, you can extend Jina with Python scripts or Docker images, specially suited for your search domain. Now, I've done enough talking. You want proof. You've seen one demo, we got more. So one of the ones I like is lyrics search. So this lets you search for lyrics in real time. It has a user-friendly front end, and best of all, it has Beyonce. So I've got another video demo to show you. So all of these demos are up on our repository. Most of them will run in Docker. And if you just want to run them in a virtual environment or even on bare metal, they're pretty easy to get going with as well. So another example, because who doesn't love Pokemon, right? So this uses a public data set of all the Pokemon sprites from the 16-bit Pokemon games, anything from Game Boy up in color, but not 3D fancy stuff from any next-gen consoles. So it'll index the Pokemon sprites, and it'll do a similarity search based on a user query. And with this, we use our GinaBox front end. So I'll switch over to that now. So here's our front end. So with GinaBox, you can search images, video, audio, or text. This time round, I'm running a Docker image on my local machine, which is, a Pokemon search example Docker image. So with this, you can drag an image of a Pokemon, like this sort of jellyfish manta ray fella here, and we can search, and similar things come up. But what if you want to search something not a Pokemon and find out what the closest Pokemon is, like this cute little axolotl? So you can try this. Cute pink animal goes in, different cute pink animal comes out. So it's doing something all right. We can even do it with photos. So your favorite star and mine, Beyonce, what does she look like? Wow. I mean, she's fierce as a singer and fierce as a Pokemon too. So that's that example out of the way. We've got a whole bunch of other examples on the website, on our examples repo. Pei Shan will be posting links to that in the YouTube comments. Our most basic example, I would say, is Hello World. So this uses the really common fashion MNIST dataset, which is a huge dataset of, I think, 24 by 24 monochrome images of shirts, tops, bags, socks, things like that. So it'll find it'll dig out a random subset and then find closest things in the whole data set that match. So there's no real user query here, it's just randomly generated. And to save time, where are we? Here's one I made earlier. So on the left, we've got the randomly selected images from the data set, and on the right, we've got a whole bunch of images that Jina thinks is similar. You could use this on the original MNIST data set as well, which is samples of writing numbers for handwriting recognition, well, not recognition, but similarity matching. So we've shown you what Jina can do. We've shown you some examples, and now how do you actually do it? So Jina has a whole family of different components that all interact together. So you can get a high-level view, a mid-level, or a low-level view. Where low level, you'd be dealing directly with the models. But on the highest level, you're dealing with the flow. So the flow deals with a specific task you want to achieve. And in search, that's generally indexing or querying. And each flow consists of different pods. These are the things that actually, the tasks that build up the flow. And we'll go into those in a bit. So it acts as a pipeline, telling each pod what to do and what the next pod in the chain is. And for building your own flow, we have 3 ways to do it. I'm a fan of the YAML route myself because I live in Vim, but you can also do it directly in Python, or if you're a more graphical person, we've got Jina Dashboard. So you can do it, you can design it all via drag and drop. Don't have to touch an editor at all if you don't want to. As I said, each flow is made up of pods. So here we've got gateway, encoder, and indexer. So if you're indexing, these are the steps you would use to achieve your specific tasks, like segmenting the input document, encoding it into vectors. In querying, you'd be ranking the top K. So yeah, if you're searching for red Nike sneakers, what is the top match? What is the second top match, and putting them in order instead of just going, blah, here are all the red Nike sneakers. Again, it's all defined in YAML, and I like to think of it as the brains of Jina, because this is the bit that uses the AI models. So as you can see down here, we've got transformer torch encoder. We've got Distilbert, which is a really common language model based on BERT that was created by Google. And yeah, beyond the flow and the pods, we've got Ps, we've got executors, we've got drivers, and Rituja will go into some of those in a bit. And then to run it all, it's as simple as Python app.py index. Or you can Dockerize it, and it's really simple to run it that way too. Once you're up and running, you can monitor it with the dashboard, and also in the dashboard, you can create your own flows. It's a low-code monitoring and management environment. And then you can use the GinaBox front end to search it, or you can build your own front end because we offer a full RESTful API. And after that, if you've built something amazing, you can upload it to a hub and share it with the world. So time for me to wrap it up. So to summarize, we do multimodal, cross-modal, text, images, audio, video, scalable, cloud native, all of that. If you want to learn more, some good places to start are Jina 101, where you can meet the different components that I talked about. My first Jina app, which is a really simple tutorial to just get you up and running and building something fast. I talked about Cookie Cutter before. It uses that. So there's almost no hands-on coding required with it. Dead simple. We've got our examples repo with a whole bunch of stuff up there. And we've got our Jina docs site, docs.jina.ai. So, yep, that's all from me. And I am now going to turn it over to Rituja. Thanks, everyone.
Yeah. I hope my screen is visible.
Yeah.
Yeah. So I'll be now diving deep into the core internals of Jina, starting with executors. So in Jina, at the moment, we have these 4 important executors.
Rituja, do you want to hit the present button to make it full screen?
Sure. Yeah. So any document is initially crafted in the sense it's subjected to different sorts of pre-processing and transformations into different chunks at which the document is broken down before it enters the encoding phase, So the encoder is when we are actually making a vector representation of each chunk. And post this, it gets to the indexer phase, where we actually try to store this indexed document. And then later on, during query time, this is used for retrieval, and that's where we sort the results. And like Alex mentioned about the Flow API, the entire context management of all these pods and executors is handled by the Flow API. So basically, we could imagine all these pods to be different microservices that are very well uh, executed using this Flow API. So as a user, I don't need to bother about where my pods are running, and I only can orchestrate it very easily using simple YAML files. So basically, each flow object would correspond to an actual task, and the entire flow, right from the pre-processing, encoding, storing, retrieval, uh, query results, all is handled by the flow. So it's essential for orchestration of pods, and we can define it very easily in Python code in YAML file, and it's backed by multi-threaded processes, and also extensible to Kubernetes and Docker Swarm. So a typical index flow looks like, as Alex mentioned in the previous slides, we have different stages, including chunk segmentation, document indexing, encode, and so on. So typically, any flow in Jina has an entry point through the gateway, and then we have different pods that are either sequential or parallel, and uh, all this is possible to it's possible to implement this flow very easily using Jina dashboards or through this YAML file. So it makes context management super simple in Jina using flow. As we mentioned, Jina supports different modalities of search. It could be either text, image, audio, or video. In this case, what's common across all these modalities is the input function for indexing. So we make sure that irrespective of the mode, the input is always in the form of a byte buffer, and we allow different functionalities like index, search, and train for feeding in the index data. So we have different crafters for different types of modes that are supported by Jina, and we allow all indexing and searching at different levels. Like if there's a text document that has several lines, we can call index lines. If there are different files, we can call index files directly and supply the input function. So next, I would move on to the concept of documents in Jina and how exactly is any document represented in Jina. So there are two important concepts here. One is that of the chunk and the other is that of the matches. So any document, if we were to look at this red block here, this is the document that we want to say query in this case. So what we do is we are breaking it down at a granularity level 1, where we are breaking it down into two chunks. So basically that's like dividing the document into different segments. So at each chunk level, we are looking at the matching chunks that are available in the indexed documents. So whenever we are trying to see anything that is matching a chunk, that's when we are looking at the adjacent chunk, adjacency in the sense similarity. So we have these concepts of granularity and adjacency, where in granularity, we are going down, breaking the document further, breaking the chunks even further. And at the adjacency level, we are basically looking at how similar is this document with the other chunks. So to imagine this as a tree structure, this is how a sample tree traversal looks like in Jina. So this is like given granularity 0 and adjacency 0. We are moving down at the chunk level, then we move down at match level, and so on. So the trick here is we move on from 0, 0 to 1, 0 and then 1, 1. We cannot move directly from 0, 0 to 1, 1. So that's an important concept here while traversing. So to illustrate this in a better manner, this is an example where we have a car. So at a chunk level, what we'll be doing is we'll be looking at having a zoomed in look inside the car, looking at smaller parts of this image. So this is where we are going down at the chunk level. So this is at level 1 and this is further down at level 2 where we only see the headlight. Then what we are doing is at this depth of level, at this depth of chunk level, we are going to find the matching images. So for this zoom in car, we get another match here, which is quite similar. Similarly, if we were to go down to the headlight level, then we find a similar headlight of the silver car corresponding to this green car. And this is like different levels at which we are trying to match. So uh, in this case, we need the parent ID for traversing all the way back to the main parent document to which the smaller chunks belong to. And we have a vector indexer that has the ID information in this case. So next I'll be talking about few design patterns that are commonly followed in Jina, starting with the concept of compound indexer. So we have two types of indexers here. One is the vector indexer. So the rationale behind having vector indexer is the concept of similarity. We want to embed documents in a similar space and compute the similarity and make sure that while retrieving or while querying and ranking the documents, similar documents were indexed closer to each other in the same embedding space. So further down, it's easy to retrieve the corresponding text for the document if we were to have a key value indexer. So these two indexers, vector and key value indexers, are often used sequentially and parallelly for different purposes. So this is a common design pattern in Jina. Next, I would talk about the text document segmentation concept. So in Jina, we introduce the concept of chunks or a recursive document structure, where we say that one document is in turn composed of multiple other documents at different levels of depth, making it a recursive document structure. And each of these compositions is a chunk, basically. So we have a crafter that segments documents into smaller parts. Also, we have indexers available at different depth levels. So it's important to note that when we are searching, that search is actually performed at the chunk level, where we follow the compound indexer pattern. And if we are to find out the actual document that corresponds to the particular chunk, that's where the document indexer comes into picture as a final step. So another important concept is what happens in index time and what happens at query time. So at index time, the two indexers, which is the document indexer and the chunk indexer, they work in parallel. So what happens is chunk indexer is responsible for receiving messages from the encoder, and doc indexer is the indexer that actually fetches the documents from the gateway. So gateway is like the entry point for the flow. So at query time, document and chunk indexers work sequentially. in the sense that a document gets messages from chunk indexer with a ranker that we have implemented called the chunk to doc ranker. And then the ranker ranks these chunks by relevance, and then it gets the parent IDs corresponding to these chunks. And then to track which document this ID belongs to, we use the doc indexer. So at query time, we have sequential indexers working. So to summarize, Jina supports a lot of different types of modes of search, and it makes sure that different P's together are embedded in a pod, and this pod acts like a microservice. It could be for different types of executors like a ranker, a crafter, uh, an indexer, an encoder, and so on. And the Flow API gives a very seamless experience in the context management for all these pods. And for refining our results to make our search even more better, we have recently introduced the concept of recursive document structure, a tree traversal while indexing, and in future, we also have plans of supporting Kubernetes and managing this entire thing that is now available as a Docker image hosted on Docker Hub also will be ported to Kubernetes. So yeah, that's it from my side.
I've just got one more thing to share, a final slide with some links if anyone wants more information. So hang on. So yeah, that's all of our contact info if anyone wants to get in touch. Or you can email me directly at alex.cg@Jina.ai.
Yeah, nice presentation.
Indeed, I'm a little mind blown at the moment. I need to unpack so many things in my head.
That's why we've got the Q&A.
One question. Is it you have images, you have text, and you store your structure, your data in documents, so you extract data out of the stuff so you can search it faster, or you can search it in the amount of time. Can I give the system any kind? Can I write this document myself so that I can, for example, use 3D data to put it in to search it?
That's a good question. I think we'd need to use libraries specific that can encode 3D data. I mean, let's put it this way. If there's a library that supports that, it can be integrated very easily into Jina. So
I understand the question, but I mean, can I put, when I have the extractor, when I can read 3D data and extract some information out of I have a bounding box, for example, and I use the length of the box or something like that. Is the API able that I can put the stuff into it so then I can search it?
Alex, can I take a hit at this one?
Yeah, of course. Go ahead.
So currently, talking in terms of just data as a 3D array, we support all the functions related to images, which are 3D arrays. And we have certain encoders or crafters which sort of detect certain things inside these images, like object detection or segmentation. So these are two different pieces. One is like the reader of the image itself, and the other is like the detector. So we currently do not have anything that you are asking for this kind of applications. but these are very easy to sort of write as small modules, and this can be added to the Jina, and the rest of the pipeline will work automatically. You just need to make sure that the requirement of these classes are satisfied, inputs and the outputs.
Okay, thank you.
If anyone wants an example of documents and chunks, and feel free to correct me if I'm wrong, everyone, like Pratik and Rituji or the experts. But in terms of recursive document structure, you could think of the document you want to index as, let's use a book as an example. So in a book, you have chapters. So each of those would be a subdocument. And in a chapter, you have paragraphs. Again, subdocuments of the chapter, so sub-subdocuments. And in a paragraph, you have sentences. In sentence, you have words. So you could search from the word level, and that would bubble up, or you could search from a paragraph level, or however you want to do it. Is that about right, Rituja and Pratik?
Yep, it's right. It's also
Yes.
not necessary to bubble up. If you want information at the chunk level also, like you can match documents to document itself, you can match chunks to chunks itself, you can do any of this combination. We just need to define that recursivity in our flows, and it will take care. So you get all the flexibility that are required for certain applications.
Yeah, you can choose the level of document you put in, you can choose the level of document you get out.
Yep, well put.
Do we have any Q&As coming up from YouTube?
Not that I'm aware of.
Maybe we can try something live. I was wondering about the Pokemon demo. I cannot. Maybe do something with the GIFs. Or do you have any other demos around which are catchy and where we could just try it out? I think you're muted.
Alex, you're muted.
Alex.
You are still muted.
Rituja or Pratik, do you have any demos you can show us?
Right now, no, it will be difficult for me to start something. But yeah, we do have other demos in the pipeline that will be coming up in examples, but cannot show it live right now.
Yeah, the problem with showing search demos is that 90% of the time you spend doing the indexing. And
Okay.
that's especially the case when it comes to machine learning, because machine learning is powerful, but it's not the fastest thing in the world. Let's put it that way.
Looking at the progress bar.
In fact, I will say it's faster in terms of the time humans have to put into it. So if you're writing a traditional search engine, you have to write all sorts of rules and a processing pipeline to do stemming, lemmatization, all of that jazz. With Jina, we're using pre-trained models that were created by Google, so they already know what they're doing. So you just throw the data at it, and it returns relevant data. But it needs a lot of time to index that data. So it's the computer that takes the time, not the developer.
Okay, then maybe a different question. You mentioned the GitHub repo and all the other URLs before. If I want to start contributing to your project, which steps are needed? How would I start contributing to your project? Maybe you can walk us a little through, maybe like sharing a screen, opening up whatever document you might have, and talk a little bit about this, or if you need resources from someone else, anything you can think of.
Sure thing. Okay, so I can share my screen now. So a good first thing is to always join our Jina.ai community Slack. Peishan is adding invite links to the Zoom and the YouTube channel, the YouTube video, I should say. So we've got a whole bunch of channels here, but the most important one is general. So this is where you can find us, where you can talk to us, ask questions, and yeah, that's the best way to get started in talking to us. And we really like people to use the general channel and not private channels for this, because, you know, sharing is caring. Let's share that information out there and let the world see it so everyone can benefit.
Additionally, there's also a support channel for specific like queries, like issues as well.
Support channel just here. We've also got the repo always has a bunch of issues. Jina.ai/Jina. So yeah, I'll bump up my font size so everyone can see. So some of these we've got some good first issues, like anything with Hacktoberfest is a good first issue. So lots of things for you to check out, for you to help with. We're also always on the lookout for people who want to contribute examples. So as I said, we've got a whole bunch of things on our examples repo. Jina 101, the first thing you need to learn. And all of these, I would suggest people start with My First Jina App, which was written by yours truly. So this lets you build your own search app that searches all the lines from Star Trek: The Next Generation. We've also got one that searches South Park, if that's more your cup of tea.
Probably Star Wars would be also a good option.
I would also suggest.
So yeah, you can run it from Docker. You can query it straight in your web browser. Earlier, I showed you Jinabox, which is just here. And this is all running on Jina's server. You just type in the endpoint of your running Docker instance, and it'll connect seamlessly, I would say. And it just works out of the box. So you don't need to install any front end. You don't need to get NPM going. You don't need to run a web server locally. Don't need to run the front end in Docker. No, just go to Jina.ai/jinabox.js and boom, it's there, ready. You can also install it on your own device if you want. It's all open source. You know, tear the code apart, do what you want with it. With querying, you don't have to use Jinabox. You can use anything that can connect via REST. So you could use curl, or you could write your own thing. Outputs in JSON, because of course it does. In terms of installation, it's pretty simple. You just use Cookie Cutter. And this tutorial, it is comprehensive. It goes through every little thing. So it is quite long, but that's because it's holding your hand, because this is the first project for a lot of people. Once you've done this project, you've already picked up a lot of info. So you can get up and running for the next ones. So yeah, and then when you want to run it, it's as simple as app.py index, which takes a while because machine learning always does. With text, it's not so bad. It might take, well, depending. If you use a lower max docs value, you'll get worse results because you'll index a lot less. But you can also get up and running a lot quicker because it doesn't need time to index so much. So it's a speed quality trade-off there. And then to run it, you just app.py search, and then you can open your web browser to GinaBox and boom, make it so, and it'll come back with output. And we go into a little bit here about flows and all of that stuff too. Beyond that, we've got Jina 101, which introduces you to the Jina family. Rituja and I both spoke a little about this. So we've got documents and chunks. So chunks are just essentially sub-documents. Everything's defined in YAML. So dead simple to use, no actual code required. The executors do most of the work, encoding, crafting, ranking, and so on. We've got a few other things like drivers, wrappers for the executors, the pods that help you get a lot of executors running in peas, running in parallel to speed things up, so replicas and sharding and all of that. And then at the top, you've got the flow, which is all about context management, orchestration, and all of that. We've got the docs site at Jina.ai with our beautiful animated GIF. So you can install via pip, you can run it via Docker, you can run it on a Raspberry Pi. Yep. Any questions so far?
Many things to play with.
I think Niklas will try it out right now.
Yeah, probably I tried to start it.
Another thing we do is every month we have our engineering all hands. I think it's the second Tuesday of the month. Peishan,
Yes.
Can you confirm? Yeah.
Yes.
So yeah, so that's when our engineers all get together over Zoom. It's a public event, public webinar.
Yeah.
Anyone can join in, ask questions, learn more about Jina there, and find out what the engineers are working on right now. And that's where you can hear from our CEO, Han Xiao. He's the brains behind Jina. Well, he's the guy who started Jina. There are many brains behind Jina now. And yeah, he's also the man behind the Fashion MNIST dataset that I demoed earlier. He started the BERT as service, GitHub Repo. He's done a lot in machine learning. We're always looking for new team members. So if you've got a background in machine learning, artificial intelligence, evangelism and developer relations, product management, reach out to us because we're growing fast. We're looking for new talent. And yeah, we've got teams in Beijing and Berlin, but we've also got a bunch of people in India, in the US, in Spain. So yeah. And at times like this, who cares where you work anyway? Nobody can go to an office, right?
Different times.
So yeah. Another thing, we recently had our hackathon not long ago. A whole bunch of cool projects came out of that, including some real-world solutions for using Jina to detect fake news, or using Jina to, how do I put it? Create inspiration for ad creators to create new social ads on Facebook or Twitter and other ways to annoy people. And we had several COVID-related projects that came out of that. We are looking at running another one probably sometime in the next 3 months. So yeah, that's another great way to get your feet wet. But yeah, the number one way would be join us on our Slack. The link should be in the chat, which is there or somewhere. I don't know where you people put your chat windows, but it'll be either on YouTube or on our Zoom chats. You can find us there, and that's the best place to reach out. We're very friendly. We're eager to support you. We don't bite much, so yeah.
Maybe you bite me now if I'm asking the question of what is the most anticipated feature in the next year's roadmap, or what is coming, and what are you personally the most excited about?
Wow, where do I even begin? It's been such a rush just focusing on getting the word out about what we already have. I haven't had time to catch my breath and see what's in the pipeline. But yeah, I'm really excited personally about seeing Jina used for real-world applications. We had another one built by Artur Tanona. He built a search system for European judicial rulings using Jina. That wasn't even at our hackathon. That was just something he did. And I'm also looking forward to integrations with other frameworks, other things. At the hackathon, someone built a hybrid chatbot neural search system using Jina and Rasa, which is a machine learning powered chatbot platform, also based here in Berlin. Pratik, Ratuja, any thoughts?
Regarding the upcoming plan?
That we can talk about, remember. I mean, yeah,
so
be very careful.
Yeah, we can give them a hint, maybe because everyone is excited about this feature, is that a lot of people come and ask us that in the current framework, we can use the models that are available, but people want to train their own model and then use them. So this is something that we look forward to, and it's a very complicated piece because we have to do it in a distributed way, in a cloud, and also support a lot of different models. So this is something that we aspire in next year, definitely.
Yeah, and I should reiterate that right now we're using pre-trained models, which are pretty damn good anyway. But there's always room for improvement for specific use cases. So yeah, being able to train is a good thing. Ratuja?
Yeah, even I agree with what Pratik said.
Cool.
So I got also a last question, or probably a question. So when is the Kubernetes release coming, probably? So when we can use it on Kubernetes?
Do we have a fixed date for that? Can we talk about a fixed date for that?
Yeah, we'll be soon also using Kubernetes. So currently we are planning to host it on AWS Infra, and we are on the path of using Terraform for infrastructure deployment. Post this, we'll be also connecting this and putting it to Kubernetes. So all the pods that we spoke about will be available as Kubernetes pods for microservices, and definitely it will help us scale out very well. So that's definitely our plan for the next quarter.
Okay.
Yeah, one of the cool things about the flow and the pods is that using a flow, you can use pods on your local machine. You can use pods running in a container, like in Docker. You can use pods running remotely, all in the same flow. No problem at all. The code is dead simple.
Yeah. Cool, thanks.
Just like Alice keeps saying, is damn simple. So I hope
Dead
that's not
simple.
giving.
Peishan, potty mouth.
Sorry. I hope that's not giving you
now.
not giving you like the wrong expectation. Yeah.
I mean, yeah. Like I said, before joining Jina, I hadn't played around with machine learning much. And after joining Jina, just playing around with this, it's ridiculously simple. It's one of the easiest machine learning things I've used.
Yeah, maybe in one of the next talks, maybe in one of the next talks, he can bring a child, a kid, 5-year-old, and then maybe he can do the things and then prove it how simple is it. For certain use cases, it's really good. Like for some well-known cases like semantic search, it really runs out of the box. Otherwise, you have to do tons of engineering. Like before working at Jina, I used to make these things customly, and it would definitely take 1 or 2 months to get something running, and to make something as robust as Jina, it would take months. Like it's not even possible to do it single-handedly. So yeah, I mean, for certain use cases, it's that simple and powerful.
Cool.
All right, we're coming up to the top of the hour.
Oh,
Oh, true. I was reading the source code while you've been explaining some things.
me too. Me too.
he's currently also set up a new model to see how many cases we can detect.
No, I was actually wondering about the roadmap a little and did it dive into the projects on GitHub, and then I found out about something about CI/CD, and then I was reading the source code. But we can also do that asynchronously. So I would say we can wrap it up here. Thanks for the great introduction, for everything you've shown us, and I have learned a lot today. I just need to find the time to write a blog post probably about it, or just dive a little deeper into it. We will share everything we've talked about today, all the URLs, all the things later on in the YouTube description and the blog post. So yeah, thanks for attending. And with that, I would just stop the live stream on YouTube.